is divided into statics and dynamics. Statics as resultant, centroid, equilibrium, and friction, and dynamics as kinematics of particles, kinematics of rigid body, and kinetics of particle. In this, you have three subtopics: D'Alembert's principle, work energy principle, and impact and collision. So this is a broad outline. We'll revisit this as and when we go into the subject. So let's start by identifying the definition of mechanics. So mechanics is defined as a branch of physical science which describes and predicts the conditions of rest or motion of a body under the action of force. So let's try to understand this example, this definition with a common example that you might have encountered quite frequently. For example, see if you have this this Hawkeye system, which is used for predicting the path of the ball of this ball after it is pitched. So it is the path is determined by using various principles of mechanics like projectile motion. Okay. Then you have impact and collision. You have Newton's second law. Then you have the effect of friction. So all these things are taken into account while predicting the path of this object. So if you see the definition, it also describes and it also predicts the motion of the body. All right. So that is what so and this prediction and description of the motion is done by application of all these principles of all these rules and principles of engineering. So now let's briefly go through the history of engineering mechanics. So if you see the history of mechanics, it can be traced back to 400 BC, where people started to use pulleys. Okay, so it can be dated so back. Then there are various names which you can go through this slide, and you must be familiar with some of the names such as Aristotle, Archimedes, who invented buoyancy and equilibrium. But the main contribution from dynamics was by Galileo. So he so mainly till 1500 the Aristotelian views were mainly supported. Okay, but most of this many of these theories were flawed. For example, he could not explain why when you shoot an arrow from a bow, it continues to move in air even after the string is no longer in contact with the arrow. Okay, so the correct principle of dynamics were developed by Galileo, and through his experiments of falling bodies. He also invented pendulum in 1602. Okay, so which is the accurate time-keeping device. Okay, so if you remember, the famous experiment was conducted by Galileo, where he demonstrated that irrespective of what is the weight of the object, whether it is a 10 kg or 1 kg, the amount of time the object takes to fall is same, irrespective of the weight of it. Okay? So but the main contribution to mechanics is, of course, by Newton's, and he put forth the various laws of gravitation and laws of motion. If you see. Uh, if you see the mechanics broadly, you can classify into classical mechanics and quantum mechanics. Classical mechanics came first, while quantum mechanics has been developed recently. Uh, Classical mechanics originated with Newton's laws of motion. Okay, and quantum mechanics is it has been developed in 1900s. And the major difference is classical mechanics deals with problem at macroscopic level, and quantum mechanics deals with problems at microscopic level. So when you deal with problems at microscopic level, the behavior of the particle is probabilistic, And in case of classical mechanics, the behavior is deterministic. You actually know where the you can actually predict the location of the particle from time A to time B, which is not possible in case of quantum mechanics. And to this Newtonian mechanics, some Einstein's general theory and special theory of relativity is applied, and it expanded the scope of Newtonian mechanics. But there needed to make some there was need to make some fundamental corrections to them. Okay? And these corrections become significant and dominant as the object approaches the speed of the light. Okay? And these corrections are also needed in quantum mechanics. Okay? So now classical mechanics is further divided into several subjects, and applied mechanics or engineering mechanics is one of these several subjects. Okay, from originating from classical mechanics. Now we'll briefly go through the contributions of Newton and how these various laws are applicable in engineering mechanics. So if you see, the most significant contribution to dynamics was by Sir Isaac Newton, and he built his theory based on the theories presented by Galileo, Kepler, and others. And he formulated these three fundamental laws of motions and laws of universal gravitation attraction, which govern the movement of objects at all the times. And he published his book, and it is translated as Mathematical Principle of Natural Philosophy, okay, by Isaac Newton. And this is just a reprinted cover page of that reprint edition of the original book. And he presented these three laws. So let's go through these laws, because we will be using all these basic three laws in our engineering mechanics. So Newton's first law states that every body continues to be in a state of rest or uniform motion with constant velocity in the same direction unless acted upon by external unbalanced force. Okay. So according to Newton's law of first motion, the Newton's law of motion can be applied to any frame of reference which is not subjected to any external unbalanced force, okay? And it is moving with a uniform velocity. Okay? So this implies that velocity is constant, that is v bar is constant. V bar is a vector. Okay. So this has some restrictions. So hence Newton's for Newton's first law to be applicable, the frame of reference should be neither rotating nor accelerating, okay? And there should be no unbalanced force acting on the frame of reference. So only if these conditions are satisfied, then Newton's first law of motion can be applied. Okay, and such a frame of reference is called as inertial frame of reference. And the resistance offered to the change in state of motion is called as inertia, which you must be familiar. Okay? For example, if you see a soccer ball sitting at rest, will continue to do unless it is acted upon by external unbalanced force of a kick to change its state of rest. As against this, what is a non-inertial frame of reference? A non-inertial frame of reference does not have a constant velocity. So it is always accelerating. And it could be traveling in a straight line with changing velocity. Such a reference frame is either accelerating or it will be decelerating. Okay. So when the frame of reference can be traveling along a curved path with a constant or variable magnitude velocity. So in that case also it is a non-inertial frame of reference. So in non-inertial frame of reference, the Newton's laws do not hold good. So for example, an elevator or a mass attached to a string rotating about a fixed axis. These are examples of a non-inertial frame of reference. So let's talk about Newton's second law, so which accounts for the imbalance force. So what it says that if an imbalance force is applied to a body, the body will accelerate in the direction of the imbalance force with a magnitude directly proportional to the imbalance force. Okay, so which is given mathematically as force is directly proportional to acceleration, and the constant of proportionality is nothing but the mass. Alternative statement for Newton's law is that the net resultant force acting on the body is equal to the rate of change in moment, which can be mathematically expressed as F is equal to D into M into V divided by M in, the derivative of M into V by with respect to time, where M into V is nothing but the moment. Thus, we can say that from this equation, the Newton's first law of motion is only just a special case of second law of motion. So if the velocity is constant, then the acceleration will be zero. So the unbalanced force acting on the body will be equal to zero. So finally, we come to the Newton's third law of motion, and the statement of Newton's third law of motion is that every action has equal and opposite reaction. Okay. So, for example, force is required to propel jet engine is also generated to action and reaction. Okay, so how does that act? The engine produce hot exhaust gas which flow out of the back of the engine, and in the reaction, a thrusting force is produced in the opposite direction. So another example can be a bat striking a ball. So in this case, the forces of interaction act between the two bodies, and if I separate the bodies, then I can get that the equal and opposite force is acting at the point of interaction between these two bodies. Okay, so this method of representing the body and separating it into individual bodies, this is called as construction of a free body diagram. What is called as construction of free body diagram. Right, so we are going to go into detail of the free body diagram, but before that, I want you to do you have any questions? If not, then I would like you to answer this quiz. I'm posting the question on the chat box. Just click on the link and let me know if you are able to access it. Are you able to open the form? Hello.
No, sir.
No, sir.
Yes, sir.
Refresh it and try it again.
Yes, sir.
Oh, so answer the question and submit the quiz.
Sir, it's not opening, sir.
Just refresh the page.
Sir, is we have to first sign in?
Yes, you have to sign in. Same sign in which you use for the Teams.
Sir, the last four questions are same and there are no options. Only 1, 2, 3, 4 is given.
Which question?
7, 8, 9, 10.
7, 8, 9. Okay. 7, 8, 9. Okay. Just a minute. Just refresh it. Now we will see only 6 questions.
Sir, are there only 6 questions?
6 questions, yes.
सर मैंने रिफ्रेश किया पर हो नहीं रहा है.
What is not like the questions are still you are not able to log in, or
No sir, I am not logged
you are
in.
not able to log in, or you are not able to see the quiz?
No sir, actually first time I will see the page, but second I'm not seeing any page. It's just saying that reload, reload.
Pardon, what did you saying? Are you
Sir, I
using
will
it
try.
on the phone, or better you use it on the PC? Not an issue if you are not able to access it. Try it later also. It is just for
Sir, it is asking to answer all 4 questions and there are no options.
all 6 questions. No? 6 questions are there.
It is showing 3 more questions.
Just refresh it. Refresh your screen. So the reason I am introducing this quiz also because you might be giving offline exam. So in offline exam, quiz is also a part of the what do you say, question paper. You have uh, descriptive question as well as objective questions.
Completed, sir.
Okay. All of you, please complete it. You must have also. Okay. I have got only 16 responses. All of you submit. If you have any questions, you can ask. You have to use your Teams sign in. Same sign in is there for them. Okay, are you done? Can I continue?
Yes, sir.
Okay, so let's continue. So if you are not able
Just a minute,
to
sir.
submit, yes. So I have seen only 25 responses.
Done, sir.
Oh, all of you submitted fast, but I can go to the next. Okay,
Done.
now let's discuss free body, how to construct a free body diagram in detail. Do you have any questions till now? All these things you have already studied in 12th, and I just wanted to refresh these things because all these things will be applicable when you are solving the example. So, do you have any questions before I continue? All right, let's continue. So let's discuss this free body diagram. So when you construct the free body diagram, first step is to isolate the body. The first step is to
Sir, your
isolate
screen is not visible.
oh,
The screen is not visible.
Your screen is not visible.
oh, correct. Is it visible now?
Yes, sir.
Yes, sir.
Oh, so let's continue
Yes.
with free body diagram. So first step when you construct the free body diagram is to isolate the body. Okay. So when you are drawing a free body diagram, only one body must be considered. So isolate the body exactly and imagine the outline of the body for which the free body diagram is to be considered. And separate the body completely from the rest of the cells. Just like I given it with the example on the earlier slide. Now next thing you have to decide is the point of application of the force. The forces are generally applied at the point of contact. Gravitational force and inertia force act at the center of gravity. Okay. The center of gravity, simply put, if you have a sphere, the center of gravity is, and if it is of uniform density, and the center of gravity is at the center of the sphere. Then identify all the points where forces are applied on the body. So after you isolate the body and you find the point of application of forces, next step is to establish the line of action. So how will you decide the line of action? So there are various methods. So one way is say for point of contact. Okay. So for a point of contact, if the surface is smooth and frictionless, the reaction can be perpendicular to the surface. Right? For example, if you have a sphere resting on this body and you have to draw the free body diagram of the sphere, then the weight of the sphere will act at the center of the sphere and it is acting vertically down. And the reaction is at the point of contact between the sphere and the surface, and it is perpendicular to the surface, and in this case it will also, the line of action of this force will be aligned to the weight. This will be the line of action of the action and the reactive force. In case of ropes and cable, forces can be can be only tensile, okay? And they act along the direction of the rope or the cable, along the length of the rope or the cable. So let's construct a free body diagram for this example. So also gravitational force acts at the center of gravity, inertia force acts at the center of inertia. and center of inertia and is not always the geometrical center of the object. And inertia forces are due to the acceleration. So let's consider an example of a simple example of a box resting on a table, and let's construct a free body diagram for this. So the first step to construct a free body diagram is to separate the box and the table. Now let us consider what are the various forces acting on the box. So let's assume that this whole arrangement is symmetrical. So the weight of the box will act at the center of the box. Assuming this is a square box. Correct? And this weight is transferred on this onto this table. So and the table will offer a reactive. Okay. This weight of the box is transferred to this table. And along the line of action, equal and opposite force will be generated in form of reaction. This is the reaction of the table. Right? And now I want to draw the free body diagram of the table. So I have to also consider the weight of the table. So the weight of the table will be transferred plus the weight of the box will be transferred to the floor, and the floor will offer some reaction. So the complete free body diagram will be there will be reaction from the flow. Okay, so this is the complete free body diagram when I separate the two objects and construct the free body diagram individually. Okay. Any questions? So let's do some few more exercises of constructing free body diagram. So let's start by constructing the free body diagram of this example. Now here 4 options are given. Okay, so based on this, see there are 4 options. Now what you want, use a rough book or some kind of a book and construct the free body diagram and identify the correct free body diagram from this, and then at the end of it we will discuss each one of them one by one. Okay. So first question is you have to draw the free body diagram of the rod and assume all surfaces are smooth. Okay, and W is the self weight and it is acting at this its center. Okay, so W is the self weight of the rod and is acting in the center of the rod. So in this 4 options are given. Select the correct option. You can construct the free body diagram in the rough and select the correct option.
First and fourth are
Hello, I cannot hear you. Just speak little louder.
First and fourth option is same.
Is it same? Just
No.
observe carefully.
No, sir.
नहीं, अरे आरबी और आरआर लिखा है ना दोनों में.
Here it is written RA and RB. So I have differentiated the 2 reactions, and here it is I have given the same name. Done with first one. Can I go to the next one?
Yes, sir.
Okay. The next example is this sphere. and it is connected to this rope, and this rope is attached to this wall, and it is resting against this vertical wall. Okay. So again, 4 options are given. Select the correct option.
Sir, what was the answer of the previous question?
I will discuss all the answers at the end.
Okay.
There are I want you to do 4 exercises. After we complete all the exercises, we will discuss answers one by one. Yeah, and keep in mind you are constructing the free body diagram of the sphere. You have to take into account only the sphere and all the forces which are acting on it. There can be more than one correct answer also. More than one correct answer is also possible. Done?
Yes, sir.
Yes,
sir.
sir.
Can I go?
Yes.
Can I go to the next one?
Yes, sir.
Next question. Right. Again, draw the free body of the sphere and choose the correct option. Alpha and theta are the angles of the semi angles of the cavity, and here it is. Alpha is not equal. And can I go to the next one? The last one?
Yes, sir.
Yes, sir.
Last one. After that, we'll discuss them one by one. So in this case, alpha is equal to theta. Done with this?
Yes.
Yes.
Okay, so now let's discuss the solution. So the first case, the correct answer is the fourth one, because the loading is symmetrical, okay, and the reaction will pass through the center of the reaction is directed, and the reaction force will be directed towards the center of the hemispherical cavity. Okay? And if you extend the line of action of W, this will also pass through the center of the hemispherical, proper hemispherical cavity, and how that comes, that we will discuss later. Okay, so this is the first. Second one, both 2 and 3 both are correct. Okay. So the tension in the spring is along the length of the cord. Right? Weight will be acting vertically downwards, and the reaction on the sphere will be perpendicular to the wall and again directed towards the center of the sphere. Right? And you can write it in this way or you can extend the line of action of RB and write it starting with the force vector, uh, starting point of the force vector at the center of the sphere. Also, this is also another way of representing the three forces. Okay, so both 2 and 3 are correct. Right? Third one, alpha is not equal to theta, so this loading is not symmetrical. So reaction at RA and RB will be, first thing, it will be perpendicular to the wall of the cavity, and reaction at A and reaction at B will not be equal, because it is not a symmetrical loading. And when I make this equal, okay, when alpha is equal to theta, then the reactions also will be same on both the points. Okay, so this is how you construct the free body diagram. Do you have any questions? Before we move on to the.
No, sir.
All right. So now let's start with the main topic, that is resultant of coplanar forces. So let's start with the main topic, that is the first topic in your syllabus, that is the resultant of coplanar forces. If you have any questions in between, you please ask immediately. So let's start by defining what is resultant. So resultant is defined as when two or more forces are lying in the same plane and are acting on a particle, then they can be replaced by single equivalent force R, which has the same effect on the particle as this single force R, and it is known as the resultant of. For example, consider a particle A, and it is acted upon by two forces F1 and F2. Then the resultant of then you can replace this force by a single resultant force R. And this R is the diagonal of this parallelogram. And R can be written as the vector addition of two forces F1 and F2. And if you want to find the now we'll find out what is the scalar magnitude of this resultant R. So for that, let's construct this in a specific manner. Let F2 be aligned with this x-axis and construct a y-axis perpendicular to F.
Sir,
Yes.
can you please show the previous slide?
Yes.
Thank you. Done, sir. Thank you.
Okay. All right. So what I'm doing is I'm constructing F2 along x-axis and perpendicular to that will be y-axis. Okay. Now after that, what we are going to do is we are going to find summation of all the forces in x direction. Now to find a summation of forces in x direction, angle between these two forces is given as theta. F1 and F2 forces F1 and F2, angle between force F1 and F2 is given as theta. Angle made by the resultant is given as with F2 is given as alpha. Okay. Now we are going to find out summation of all the forces. So F1 and F2 are the two forces and this resultant is R. Okay. So either you have F1 or F2 or you have R. You don't have all the three at the same time. Okay. So let's resolve forces F1 and F2 all on x and y direction. So F2 is already along x-axis. So when I resolve it along x-axis, the x component of F2 will be F2. Okay. Now to find the x component of force F1 along x-axis, what do? I multiply F1 by cosine of the angle. So it will be F1 cos theta. Okay, so summation Fx will be F1 cos theta plus F. And this will be also equal to R cos alpha. Right? Similarly, let's find out what are all those forces in y direction. So let's do summation F1. Okay. So F2 force doesn't have any component in y direction. Only F1 force will have component in y direction, and that component is given as F1 sine. So we have resolved force F1 along x and y axis. So this is F1, and F1 along x axis is F1 cos theta, and F1 along y axis is F1 sine theta. Right? So this is how you resolve the force. Right? And similarly, the R component will be in y direction will be R sine. Now let's square and add all these terms. So summation Fx square plus summation Fy square is equal to F1 cos theta plus F2 whole square plus F1 sine theta square, and this is equal to R square cos square alpha plus R square sine square. Right? Now let's expand this. Let's put this one on left hand side and this one on right hand side. So when I expand this becomes F1 square cos square theta plus 2F1 F2 cos theta plus F2 square plus F1 square sine square theta is equal to R square, and let's take R square common. So it will be sine square alpha plus cos square alpha, and that is nothing but equal to R square. Okay. And similarly, I can collect these two terms together and I can write it as F1 square cos square theta plus sine square theta plus 2 plus F2 square plus 2F1 F2 cos is equal to R square. And again, this becomes equal to 1. This is also 1. So I can write R square, or I can simply write R taking the square root as F1 square plus F2 square plus 2F1 F2 cos theta. Okay. Any questions? All right. Now I want to
No, sir.
find the angle made by made by the resultant with F2. So how do I find out? So let's call this equation as 1 and this as 2. So let's divide equation 2 by 1. So that gives me tan alpha is equal to F1 sin theta divided by F1 cos theta plus F. And if I write it in terms of external angle, okay, so this is the theta is the included angle. If I write it in terms of external angle, that is 180 minus theta, then I just replace the minus sign with the plus sign with the minus sign, and I write it cos of 180 minus theta. All right. Any questions?
No, sir.
All right. So let's continue. If you have any questions, you should interrupt me. Yeah? So accordingly, I can adjust the speed. So I can also find the resultant by using the triangle rule. So let's see what is this triangle rule. Okay, and sometimes it is also referred to as sine rule. Okay, so what I can do this in two ways. This is the parallelogram. The diagonal of the parallelogram is the resultant. Now this force, the opposite sides are parallel. So instead of having this F2 over here, I can move this F2 at the top. So I can write it in this way. So I can construct this triangle, or I can write F1 over here. Right? So one of these two methods I can write. And if I know the angles between the two adjacent sides, then I can apply the sine rule, and I can say that F1 divided by sine alpha is equal to F2 divided by sine beta is equal to R divided by sine. Yeah. Okay. So if I know this three angles, 1, 2, and 3, and if I know one quantity, then I can find out the other two, and I also find out the result. Now this what you say sine rule I can, or law of triangle, I can apply it to more than 3 forces also, but then I have to apply it in chain. Okay, so what do you mean by chain? So first, if there are more than 2 forces, so there are 1, 2, 3 forces, and this is the resultant. So in that case, what do? I have to take 2 forces at a time. Okay. So resultant of P and Q will be P plus Q. That is a vector addition. P bar and Q bar. So vector addition. So that will be the resultant of P bar, P and Q. And then this resultant will be this another vector addition of P, Q and S. So in that way, I can apply the law of triangle, and I can find out the resultant of more than 3 forces also. Okay. All right. So let's do a simple example on whatever we have learned so far by solving this example.
Sir, can you show the previous slide?
Yes.
No, the slide before this.
This one?
Yes. Thank you. Done.
Right. So two forces P and Q are applied at a point A of the hook. Determine the magnitude and direction of the resultant using law of parallelogram of force. Okay. So let us construct a parallelogram. Let's construct a y-axis and x-axis. Construct a parallelogram, and is 15 newtons is 25 newtons. So I'll just draw it a little bit longer, and then I'll just complete the parallelogram. And diagonal of that will be the resultant. The resultant R, this is 15 newtons, is 25 newtons. And this is given as 15 degrees and this is 30 degrees. So total angle is how much? So 15 plus 30, so that is equal to 45 degrees. Okay. So let's say this is theta. Okay, so what will be the resultant? So let's call this as P. This is, let this be P and this is Q as it has stated. Okay, so resultant will be P square plus Q square plus 2PQ cos theta. And P is 15 newtons, Q is 25 newtons, and theta is equal to 45 degrees. So calculate and tell me the value. Done? Yes, you can tell me the value. How much is R? Anyone?
37.15.
37.
Sir, 37.14.
Correct. 1514. That is the resultant. Okay. Now let's also calculate the angle. All right. So if I want to, let's say I want to calculate this angle phi. So phi, tan phi, using the formula which we have just read, will be Q sine theta divided by P plus Q cos theta. Find out this angle phi. How much is phi? Everybody is familiar with the scientific calculator, no? Hello.
$28.41 degrees.
Correct. 28.41 degrees. Okay, so that is the correct answer. Now I want to find out the angle made by this resultant with the horizontal. Okay, I want to find this angle alpha. Correct. So how much will be alpha? So alpha will be 90 minus this small angle. Mark it with a different color. 90 minus this angle. Right? So that is how much this is 15 degrees. Angle is 15 degrees. Okay. So that will be 90 minus this small angle, and that angle is phi minus 15 degrees. That is the angle alpha made by the resultant with the horizon. So whenever you write a resultant, you have to show the magnitude and direction. The magnitude is R is 37.15, and angle either you show it with the horizontal or with the vertical, and so this is how you represent it. So calculate this angle and tell me what is the value.
76.59.
76.57
Approximately 77.
degrees. Okay, 76.59 degrees. Okay. 76 point. All right. Any questions up till now? All right. I think we are good. We'll stop here today and continue the rest of the content in the next lecture. Okay, so we'll continue with resultant. So before I end the session, do you have any questions? Specific questions? I cannot hear you. Books. Hello. I did not hear you. Your voice was very low.
So
Books,
can you tell us
Sir,
about the
reference book.
reference book? Beer and Johnson is a good book. Johnston. And Merriam and Craig. Good illustrative diagram.
So can you
And
repeat?
if you just want to practice, you can use any Indian author book which is available in the market. There is no harm. Right? Any book you can use for practice. Yes, if somebody was asking something and I interrupted. Hello.
Sir, can you share this PDF?
Yes, yes, I will share it. In the Teams, there is a folder in this files. This is your team. Your team. Your team. Okay. So in this, you are able to see the screen. No? So in this files, there is this folder called class material. Okay. So in this folder, I will put all the files. Make a folder. Notes. I will push the PDFs in this. Okay. I will post it after some time. All right. Okay. Thank you for that.
Yes,
See you in the next.
Sir,
Yes.
Thank you, sir.
so that assignment was graded, right? The one which you
So
sent.
it is just for your self evaluation. It is not what you say part of your term work or something like that.
Okay,
Just
sir.
a
Sir,
part of self.
आपने जो
Yeah. Go
सर
on, please. Yeah.
आपने जो लिंक भेजा था ना वो क्वेश्चंस का
हाँ.
वो पूरा दिन तक चालू है ना मतलब
चालू
उसका
है,
कुछ
चालू. It is open. No, it is not. It will not be locked. It will be open. You can solve it anytime. If you have any
Thank you.
questions, post it on the group chat. I will get that message. In the Teams, there is a chat, so you can post it on that.
Yes.
If you have any doubts, so you can, I will respond to that. All right. Thank you very much. See you in the next lecture. Bye.
Thank you, sir.
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 Thank you, sir.